This is an overview video for College Trigonometry version 3 by Stitz and Ziegler. 10.5 Graphs of the trigonometric functions. We're starting with graphs of the cosine and sine functions. First off, when considering the graph of cosine, sine, secant, tangent, cosecant, cotangent, all 6 of these functions are what's called a periodic function. Now a periodic function is one, it's periodic if there's a real number such that the function will repeat itself after a certain amount of time has passed. Over and over and over and over. And the smallest possible positive number p for which that repeat happens is called the period of the function. This will make a little more sense when we look at a graph later on. Some reminders of the properties of the cosine and the sine functions. For cosine, the domain is all real numbers, and the range goes from negative 1 to positive 1, including those two values. It is continuous and smooth, no breaks, no gaps, no vertical asymptotes. It is an even function, and it has a period of 2 pi. For the sine function, the domain is all real numbers. The range is the same as the cosine, from negative 1 to positive 1. It is continuous and smooth. It is an odd function, and it also has a period of 2 pi. When looking at the actual graph for a cosine wave, one of the best ways to do this is to go back to just a basic unit circle with these 4 points, the intercepts. These are easy points because this point is 1, 0, this is 0, 1, etc. And the values, this is 0 or 2 pi. Should put a little comma 2 pi right there. And pi halves and pi and 3 pi halves. And also remember that these points are in cosine, sine ordered pairs. So when we're looking at 0 radians, cosine, which we're doing, is 1. And here we have 0, 1, the point 0, 1. This is where the cosine starts. The next nice point is pi halves, and cosine is 0. Pi halves 0. Pi negative 1. 3 pi halves 0. And finally 2 pi 1. These points would give you this information. Again, the 1, 2, 3, 4, and 5. Again, those are called the 5 key points, and it makes a very simple way to remember how the cosine function looks. Now the extra points, the pi fourths, the 3 pi fourths, 5, and 7, you can just go off of the unit circle to get these values. They just give you a little more information about how the cosine travels between these points. What we're looking at is one full cycle of the cosine wave, because the cosine has gone all the way once around the unit circle and is about to repeat itself. This gives us, this part of the graph is a period of the cosine wave. So this cosine wave will continue on in this pattern over and over and over and over as we move around and around the circle. So we have one period. The period of cosine is from 0 to 2 pi. The fundamental cycle of y equals cosine x. Many books refer to these 5 key points, specifically the 5 key points. 1, 2, 3, 4, 5. Let's take a look at sine. In looking at the graph for the sine wave, the 5 key points for the sine wave are located on these spots, and they're easy to get. There they are. They're easy to get if you remember the basic unit circle, and just the 4 intercepts are enough. So recall that these points are cosine sine pairs, so we're looking at the sine. This value is also 2 pi, that's useful. The sine wave, so at 0, sine is 0. That gives us 0, 0. At pi halves, sine is 1. At pi, sine is 0. At 3 pi halves, at 2 pi. 2 pi, sine is 0. So these 5 key points make a very simple graph if you're able to quickly get them, and using this circle is a very nice way to get those 5 key points. These other points help you with the curvature of this graph, and that's just plugging in pi fourths and 3 and 5 and 7 pi fourths and using reference angles and quadrants if you need to. This is one period of the sine wave. The sine wave will continue this pattern over and over and over as we move around both ways around the circle. Sine repeats itself after a period of 2 pi. So the period of this sine wave is 2 pi. Taking a look at a specific example, we'll notice this cosine wave has a bunch of other information involved. However, this book chooses a way that all of this extra stuff doesn't really make it much more difficult. First off, we look at the x value of the 5 key points for cosine. Here they are, and they are always those 5. What this book suggests you do is take the inside of the cosine, in this case pi x minus pi all over 2, and set it equal to the 5 key x values of the 5 key points. When you do this, you'll get 5 equations. For example, this first equation, you would first multiply by 2 and it would disappear into the 0. You'd add pi, and then you divide by pi and get pi over pi, which is 1. So what this will do, solving each of these equations, will generate the 5 new key x values. You then take these x values, for example the 1, and you plug it in to x. So let me show you one example. Let's see, that's not going to work too well. There we go. That'll work fine. So we would have f of 1 equals, it'd be 3 cosine of pi times 1 minus pi divided by 2, and all plus 1. I did run out of space. Evaluating this, 1 times pi is pi. Pi minus pi is 0. 0 divided by 2 is 0. So we get 3 cosine of 0 plus 1. Now cosine of 0 is 1. So we have 3 times 1 plus 1. And we end up with 4. That's what they're doing here. They're taking all these x values and plugging them into the function and getting new y values. This is how this book generates the 5 key points. This process they use on every one of these 6 trig functions. So once you get used to it, it flows nicely. It may not be the most efficient way that I know, but it works well every time. So it's a nice way to go. Once you have this graph, you can take a look at what the period is. Starting from here and going to here, we're going from 1 to 5. This period would be 4. If this problem had been a sine, you would still use the same x values of the key points, and you would still set them this inside equal, and you'd still get these same x values, but when you plug them into the sine, the y values of the new key points would be different, giving you a different graph when you're done. So most of this process is the same for the sine wave as well. This book introduces sinusoids. Sinusoids can be characterized by 4 properties: period, amplitude, phase shift, and vertical shift. So this case is a sine sinusoid. You could also have cosine sinusoids. Essentially, the previous example is a sinusoid. You have the basic sine and the basic cosine, and when you start moving them around, you get what's called a sinusoid. They talk about the baseline, and the distance from the baseline to the top or from the baseline to the bottom is called the amplitude. The amplitude is a distance, so make sure that it's always positive. Even if there's a negative sign in the function right here, the amplitude's positive, and notice they have the absolute value to make sure that's true. The period is for the distance for one cycle. So omega being the angular frequency, if you have a function in this form, a cosine omega x plus phi plus b, to get the period for cosine is usually 2 pi, so it's 2 pi, the usual period, divided by omega, the coefficient of x. Same with sine. The period is the regular period, 2 pi divided by omega. The amplitude is the absolute value of the coefficient of the sine or the cosine. The vertical shift is the constant term. Notice there's no x, there's no cosine, anything else. That's just a single term out there, a constant. And that moves it up and down. That changes the baseline. And finally, the phase shift. This form is not standard in a lot of books, but it's used in this one. If you were to set that equal to 0 and solve, you would get the phase shift. You can also factor out the omega. And then, as usual with transformations, when you have a x plus, that ends up moving it left, and your phase shift would be negative. So there's two ways to get the phase shift from this form. And that's what the book calls sinusoids.